Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello, welcome again to the television learning program. I'm teacher John. I'll be taking you through mathematics senior 6. Students, mathematics needs a notebook, exercise book, calculator, mathematical set. Because you have to write notes, exercise, homework, and other activities. You have a few minutes, few seconds even to get ready. Are you ready? Yes. Let us start with activity. That activity is about limit. Mathematics, senior 6. We started by activity. Evaluate the limit of ln of x plus 3 divided by 2 plus x is x approaching minus 2 to list other kinds of if, I mean indeterminate form. You have 1 minute. Go on. Hurry up. Are you done? Not yet. Few seconds. Few seconds. Are you done? Wow, thank you very much. Now follow here on the chalkboard. We are going to make the correction, and thereafter you will compare the answer and what you have got. Solution for the first. Limit is x approaching minus 2 of ln of x plus 3 divided by x plus 2 plus x is equal to limit x approaching minus 2 ln of minus 2 plus 3 divided by 2 minus 2. And you have ln of 1 divided by 0, and you know that ln of 1 equals 0. So we have 0 divided by 0. This is known as IF, indeterminate form. Are you together? Are you together? Yes, thank you very much. We are going to remove this indetermination by using the hospital's rule. I think I still remember how the hospital rule works. Now, the limit is x approaching minus 2 of ln of x plus 3 divided by 2 plus x equals the limit x approaching minus 2 derivative of ln of x plus 3 divided by the derivative of 2 plus x. Pay attention here. Most of the time you make mistake when you apply the hospital's rule. You differentiate the numerator, and thereafter you differentiate the denominator, not the derivative of a quotient. Are you together? Are we together? Yes, thank you very much. Now, the derivative of ln of x plus 3, as you know, ln of u, derivative is the derivative of u divided by u. For us, u is x plus 3, and derivative of x plus 3 is 1. So it means we have limit x approaching minus 2 of 1 divided by x plus 3 divided by the derivative of dt is 1. It will be having the limit of x approaching minus 2 of 1 divided by x plus 3. This is equal to limit x approaching to minus 2 of 1 divided by minus 2 plus 3, which is equal to 1. Finally, the limit of ln of x plus 3 divided by x 2 plus x approaching minus 2 equals 1. The other activity was to list other kind of indetermination. Starting by this one, 0 divided by 0, we have other kind of indetermination taught in senior 4 and senior 5. Those indetermination are infinity divided by infinity. You remember? We have also 0 times infinity. You remember infinity minus infinity, and so on. And you know how to remove this kind of indetermination. When you have this kind of IF, especially for infinity divided by infinity, and the 0 divided by infinity is 0, if you are not able to simplify, you apply the hospital rule. When you have this kind of indetermination, 0 times infinity, you have to bring this form in one of these, infinity divided by infinity, or 0 divided by 0, so that you can apply the hospital's rule. And for this kind of indetermination, you have to conjugate and then you simplify. Are you together? Yes, thank you very much. We have other kind of indetermination, such as 1 power infinity, infinity power infinity, 0 power 0, infinity power 0, and so on. To deal with this kind of indetermination, we have to think about other limits, and those limits is our purpose of today. We have unit 2, logarithmic and exponential. Functions and then with this unit dealing with logarithmic and exponential function, we are talking about limit of logarithmic and exponential function. Are we together? Yes, thank you very much. We have a record of some important limits. When you have those kind of indetermination, you have to use the following limit. They are very important and known limit. Limit is x approaching 0, 1 plus x power 1 over x is equal to e. And from this, we deduce the limit of x approaching to 0, 1 plus x power k divided by x is equal to e power k. And the limit x approaching to infinity, 1 plus 1 divided by x power x equals e. And from this, we have the limit is x approaching to infinity, 1 plus k over x power x is also equal to e power k. K is a real number. These known limits are very, very important, and they are going to help us to deal with those kind of IF. I give you few seconds to write down these limits in your record book for reference. And thereafter, you have an example. Are we together? You have encore a few seconds. Yes, I think you are done. Stop. Follow the example where we can use this kind of limit to remove those IF. Evaluate the limit of x minus 3 divided by x plus 1 raised to power 4 as x approaching to infinity. We have the limit x approaching to infinity. When the limiting value is infinity, here we have a quotient. The numerator is of the degree 1. Denominator is of degree 1. It means the limit will take the ratio of leading coefficient. And here we have 1 power 4 times infinity is infinity. This is equal to 1 power infinity. And this is IF in the determinate form. Are we together? Are we together? All right. Now, to remove this indetermination, we are not able to apply the hospital rule. But we can introduce ln function so that we can come back this limit and we find our limit. So for that purpose, we let y equals limit x approaching to infinity, x minus 3 divided by x plus 1, raised to power 4x. And this is introducing ln both sides. We'll be having ln of y, which is equal to the limit x approaching to infinity, 4x ln of x minus 3 divided by x plus 1. Here I used ln of x power n, which is equal to n times ln of x, properties of log function. Now, we have ln y, which is equal to limit x approaching to infinity. 4 times infinity is infinity. Ln of x minus 2 divided by x plus 1 is ln of 1. Ln of 1 is 0. We have infinity times 0, which is also if. From this indetermination known from senior 4 and senior 5, we are free to apply the hospital's rule by letting this indetermination in one of the form, either infinity divided by infinity or 0 divided by 0. Are we together? Are we together? Right, thank you very much. Now, we can write ln y equals the limit x approaching to infinity, the ln of x minus 3 divided by x plus 1 divided by 1 divided by 4x. I think there is no change because a fraction divided by another fraction, you have to reverse the fraction and deal. There is no change from what you have here, right? Thank you very much. Now, we know that this limit is already ln of 1. And there we have 1 divided by infinity. And ln of 1 is 0. And here I have a 0, which is if. Then we apply the hospital rule. Allow me to remove this because we have already we are going to apply the hospital's rule for that if. So it means ln of y is equal to the limit x approaching to infinity, derivative of ln of x minus 3 divided by x plus 1 divided by derivative of 1 over 4x, like this. Then derivative of this numerator, let me do my draft here. We know that ln of x minus 3 divided by x plus 1 equals ln of x minus 3 minus ln of x plus 1, properties of ln. Then differentiating these ln of x minus 3 divided by x plus 1, this will be equal to derivative of ln of x minus 3 minus derivative of ln of x plus 3. And we get 1 divided by x minus 3 minus 1 over x plus 1. Are we together? Thank you. Then, putting on common denominator, we have x minus 3 times x plus 1, 1x plus 1 minus x minus 3. We'll be having what? 1 minus 3, this is 4, divided by x squared minus 2x minus 3. This is my draft derivative for the numerator. And I continue with derivative of my denominator, which is 1 divided by 4x. This is 1 over 4, a constant, 1 divided by x derivative. And this is 1 over 4 times minus 1 over x power 2. It means we have minus 1 over 4x squared. Are we together? Thank you very much. Now, I go back there. We have the limit, ln y equals the limit x approaching to infinity. My derivative was 4 divided by x squared minus 2x minus 3 divided by minus 1 divided by 4x squared. I'll be having ln y equals the limit x approaching to infinity. Are we together? Thank you. 4 divided by x squared minus 2x minus 3 times 4x squared divided by minus 1. This is minus the limit x approaching to infinity, 16 x squared divided by x squared minus 2x minus 3. This is equal to minus 16 because the limiting value is infinity and the degree of the numerator is 2 and degree of the denominator is also 2. We take the ratio of leading coefficient. Here the leading coefficient is 16. Leading coefficient is 1. Then 16 divided by 1 is 16. With our minus sign, we get minus 16. Are we together? Great. Now we have ln y equals minus 16. It means if you introduce ln both sides, ln y is equal to ln of e power next 16. Means that y equals e power minus 16. Remember that y was the limit. We can respond to our question. Therefore, a limit of x minus 3 divided by x plus 1 result power 4x is x approaching to infinity is equal to e power minus 16. This is our limit using the general method. This is known as the general method. Do you understand? Any comment? Thank you very much. Now, take few seconds to copy down this example, then you get another one for activity. Hurry up. Hurry up, please. So here you are with your activity. You have 1 or 2 minutes. Please hurry up. Hurry up. Hurry up. You are done with this. Hurry up, please. Are you ready? Are you ready? Not yet? So you still have a few seconds. Can you make the correction? Good. Okay. Let us start by this one, because this looks like a new one, but the second is not different from the first. So we are going to correct this number one. The following will work as auto-evaluation. Now, limit x power x is x approaching to 0. This is 0 power 0, which is in determination. So we let y equals the limit of x power x is x approaching to 0. This is ln of y, which is equal to limit of x approaching 0, x of ln of x. Introducing 0, you have 0. Ln of 0 is negative infinity. This will be 0 times minus infinity, and this is if. So we'll be having ln of y equals the limit x approaching to 0, ln of x divided by 1 over x, and you apply the Hospital's rule. We have ln of y, which is equal to the limit x approaching to 0. Derivative of ln of x is 1 over x. Derivative of 1 over x is minus 1 over x squared. And this is the limit x approaching to 0, 1 over x times x squared divided by minus 1. And this is the limit x approaching to 0 minus x, which is equal to, replacing x by 0, you get 0. It means that ln y equals 0, and this is ln y, which is equal to ln of e power 0. It means y equals e power 0, which is equal to 1. Hence, limit x power x is x approaching to 0 equals 1. We are done. Thank you very much. We have a homework here. The homework is here. Evaluate the limit of x approaching infinity of x squared plus 1 divided by x squared minus 1 raised to power x power 2. 2, limit of x approaching infinity of x divided by x plus 1 power x plus 2. 3, limit of sine x raised to power tangent x is x approaching 0. And the last is the limit of x plus 3 power 4x is x approaching to infinity. Thank you very much. Stay at home. Do mathematics every day. Mathematics is very, very, very simple, but it needs the hard working. Thank you very much. We'll meet again next time. All the best.